This quadratic is in standard form, so I want to determine the number of zeros. It will either be 0, 1, or 2. Remember, the graph can either not cross the x-axis, which means it has two imaginary solutions, no real solutions. It can barely touch the x-axis right on the vertex, which means it has one real solution that's repeated. It still has no imaginary solutions. Or it could cross the x-axis twice. It could have two real solutions and no imaginary solutions. So this is 2 real, 0 imaginary. This is 1 real that's repeated, 0 imaginary. This would be 2 imaginary and no real. It just depends on the number of times it crosses the x-axis. When you are in standard form, you can use, remember the quadratic formula is this whole thing. But remember, negative b over 2a, that's what tells you the axis of symmetry. And so this, the plus and minus this piece, is telling you, oh, remember the axis of symmetry is right in the middle, and then you have one x-intercept on each side of it, exactly that far away. So if you're at the axis of symmetry, if you go plus this part, you get to this x-intercept, and if you go minus this part, you get to the other x-intercept. So it's really this thing that's telling me about the x-intercepts. And I really only care about the part that is underneath the square root, the b squared minus 4ac. That is what's called the discriminant. And that is going to tell me the number of, and type of solutions that I have. If I get a positive number underneath my square root, then I'm going to have 2 real solutions. So if the discriminant is greater than 0, then I'm going to have 2 real solutions. Because you can take the square root of a positive number, no problem there. If the discriminant is less than 0, if this number under the square root is a negative number, that means you're going to have 2 imaginary solutions. If the discriminant is equal to 0, this is when people get confused on the most. If this number is equal to 0, that means that you're just at the axis of symmetry. You're not plussing or minusing anything, which means that you must be, your axis of symmetry must be the point that you're at. So in this case, you're going to have 1 real solution. Still no imaginary solutions. That 1 real solution is just going to repeat. So let's do the discriminant with this problem right here. Remember, a is right here, a is 1, b is positive 4, and c is negative 2. So you're going to do b squared minus 4ac. 4 squared minus 4 times 1 times negative 2. I'm just using a, b, and c right here. Follow order of operations. This gives you a 16. This is a negative 4 times a 1, so negative 4 times a negative 2. That's a positive 8. So based on what this number is, and based on this right here, you need to tell me the answer. If the number is positive, if it's bigger than 0, you get 2 real solutions. If it's less than 0, you have 2 imaginary solutions. If it's equal to 0, you have just 1 repeated solution.